Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and welcome back to 3D Collisions in GameMaker. So the last video in this series was a little bit on the short and not so complicated side, at least I hope, and it was all about working out a system so that any two arbitrary shapes can detect collisions against each other without having to have any knowledge of what type each shape is. And I said that was going to be very nice to have when it came to organizing a bunch of collision objects into a single game world, and that is what we're going to be doing today. So I've said something a few times about how the acceleration structure that I wrote for triangle meshes is going to be a little bit, if I can find an appropriate level of zoom here, a little bit similar to the acceleration structure that we are going to be using for the collision world as a whole. And that's what we're going to be doing today. We are going to be taking the concept of the octree and applying it to not just a triangle mesh full of a bunch of triangles, which are expensive to compute collision detection against, but to the game world as a whole, so that we don't have to deal with checking for collisions between two objects that are completely on the other side of the map from each other. It's not going to be the same, so if you go into call mesh, the octree that we're going to be using isn't just going to be copy and paste from the collision mesh to the collision world, but it's going to be pretty similar, and if you were paying attention during that video, then this one is hopefully not going to be that complicated. So let me start by going into the call_world code file and defining another struct. I'm going to say function ColWorld. And let's see, I'm going to give this a few parameters. One is going to be bounds min, another is going to be bounds max, and a third is going to be max depth. And this is going to be a constructor. Before I begin, I would especially like to draw attention to the fact that I pulled inspiration for this video series from a number of different sources, Game Physics Cookbook being probably number one among them. But there are plenty of other philosophies that people have about 3D collision detection, and more especially how to organize such things into a single world data structure. And what I've worked out for this video is going to be what I, one, think is going to be easiest to explain, and two, what I have found works best for purposes of 3D collisions in GameMaker. I'm going to try to make a point to point out different places in this code where people might use different philosophies. That statement has been true for pretty much this entire video series, but there are many, many different ways that you can organize collision objects into a world, and some of them might look very different from this. So I figured I should draw special attention to it now. So let's get into this. I'm going to define a few things. One is going to be self.bounds. This is going to be the boundaries of the collision world. I'm going to say bounds equals new call ab from min max. The minimum and maximum values are predictably going to be bounds min and bounds max. So speaking of different ways to approach this problem, you might prefer, instead of defining a collision world with a set size, bounds min and bounds max, you might instead want to initialize the collision world with an array of objects and then calculating the bounds from there, the way that we did with the triangle mesh. But I'm going to instead opt for a system that easily allows you to add and remove objects during runtime. And initializing the collision world to a set size ahead of time is going to make that a little bit less work on our part. Next, I'm going to say self.acceleration structure. Self.accelerator is going to be initialized to... Oh, let me check my notes. I'm going to call this a new ColWorldOctreeNode. This is going to have a lot in common with ColOctree, and in fact, I might actually just copy and paste the code and make modifications to it from ColOctree instead of writing it over from scratch. There is going to be a lot in common. The parameter list I will not worry about for now. I will fill that in later when I actually get around to implementing the WorldOctreeNode, and then self.depth is going to be set equal to max depth. Depth. I hate the PTH sound in English. It's the worst. Now let's define some methods. We're going to have a couple easy ones. So static add is going to be equal to a function. It's going to take an object. I'll fill that body in later. Similarly, static remove is going to be a function. It's going to take an object. One of these is going to deal with adding an object to the collision world. One of them is going to deal with moving it. I'll let you figure out which is which. Next, static update is going to take an object. This is going to be when, for example, an object moves and you want to update its position in the hierarchy. I'll do this one right now. This is going to be a simple matter of self.remove the object and then self.add the object. So to update something's position, we're just going to remove it and then we're going to re-add it. Nice and easy. Next, static check object is going to be a function which takes an object. And this is going to perform a collision check between one object and all the other objects in the collision world. And the partner method that goes with check object check ray is going to be a function which takes a ray. And considering right now, do I want to actually pass a hit info into this check ray method like I do with all the other ones? Or since this is kind of like the granddaddy of all the check ray methods that we're going to be using, do I want to just like create a hit info struct and return it as a result of this method? I think I'll actually go with the latter because that would make it a little bit easier to use this system in development. Okay, so let me go create myself a new branch on GitHub. So this is going to be week 19. I am going to bring my changes over, thank you. And this commit is going to be defining the collision world structure. All right. Now let's talk about ColWorldNode. So I said I was going to do some copy and paste. Let me copy that. I'll paste it into the same code file here. So again, same deal as with the collision mesh structure. This is going to be a recursive data structure, a recursive octree structure, and we're going to split it to a certain depth, and we're going to put things inside each of the subdivisions. So let's see what we have to work with here. Okay, so instead of instantiating an octree and then like immediately splitting it the way that we did in the mesh octree system, I'm going to name this something else. Let's call this ColWorldNode. Okay, I called it node the first time. I guess for consistency's sake, we could call it ColWorldOctree like that. Consistency is a good thing, right? So the two arguments that the constructor is going to take is going to be the bounds. So that's an access align bounding box representing the bounds of the OctreeNode. And instead of a triangle mesh, let's go with a depth. And update the names of all the variables in question accordingly. Instead of having an array that's called triangles, I'm going to create an array called contents. And that's not gonna, it's gonna serve the same purpose, but instead of just only dealing with triangles, and thus the array being called triangles, we're going to be containing a bunch of different collision objects. So I'm just gonna call this contents. I guess if you wanted, you could call it objects as well, but in my notes I called it contents, so I'm gonna go with that. Children, these are the subtrees. So any inner octrees that this is gonna contain will be in here. This will be an array. Debug draw, I think I can get rid of that because I think I demonstrated how that works the last time and I don't think I really need it anymore. The split method, and I suppose I can collapse the asset browser on the side of my screen so that you can see the whole thing. This is going to have a few changes. One, depth is no longer going to be a parameter because that is going to now belong to the OctreeNode itself. I suppose if you wanted to, you could go back and like rewrite the other, like the old OctreeNode code so that it would work the same way, but no big deal. If array length self.triangles equals zero, we're going to return. Same thing here, except instead of triangles, it's going to be contents. If self.children is not equal to undefined, we're going to return, and we're not going to do any splitting because this node already has been subdivided, and we don't need to do it again. calculating the center, calculating the side length. That's good. Initializing the array of children, of the child octrees. That's going to be good. We don't need to make any changes except that we need to update the name of the struct that we're instantiating. So call world octree like that. And at the end, so that our the arguments that we're giving it match the arguments that are expected. Instead of passing in self.mesh as the second parameter, because we no longer need that, we can say self.depth -1, so that we know what the depth of each subtree is. It's going to be 1 less than our current depth, so you can't subdivide an octree infinitely. And then down here at the bottom, after the array of children has been created, we're going to do something similar to what we had before. For each subtree, we are going to loop over the contents of our own octree, and we are going to say tree.bounds.checkTriangle. So this line here, this is where we're going to start diverging a little bit from the octree that we created for collision meshes. If tree.bounds.checkTriangle, then array push the triangle onto the subtree's triangle list, and then when you're done, split it again at a level of depth -1. First, I'm going to get rid of the split method there, because as I believe I've said, we're going to be only subdividing nodes in this octree when we need to, like when things are added or removed, and we're not just going to be automatically doing it for the entire tree at the beginning. Let's see. I also deleted this. These 3 lines here, this if statement. We're going to be implementing something similar, but it's not going to be exactly the same. For now, for the collision world octree, I'm just going to say I'm going to say tree.add self. And this needs to be contents instead of the triangles array. Self.contents index j. And again, this is going to be done recursively, and we will be defining some of these in a minute. So let me create the outlines for these next couple of methods. I'm going to say static add. It's going to be a function which takes an object as a parameter. Static remove. It's going to be a function which takes an object as a parameter. Static check object. And check ray. The check ray method for world octree nodes will take a hit info struct as a parameter, unlike the check ray method in collision world, because the collision world check ray method, as I said, is kind of the granddaddy of all the check ray methods that are in the system, and this will create a hit info struct that it uses and passes to each of the shapes that it checks, so that you don't have to do it yourself every time. Anyway, let's go with let's deal with the add method first. So, to start with, we will only add an object to a collision world octree node if object, and this is a collision object, not an actual shape, so we can say object.shape.check ab against the self.bounds. So first we're going to check the object against the axis-aligned bounding box representing the size of the octree node to see if we're actually inside it, and consequently whether or not we should actually be added to it. You could put this in an if statement. I'm going to do kind of what I've been following, like code design-wise, and say if not object.shape.checkAb self.bounds, we're just going to return, and we're not going to do anything. There's going to be a few cases which are going to cause us to exit out of various add and remove and whatever methods early. And I don't really want to chain that many if statements together. Likewise, if a collision object already exists within an octree node, we will not add it again. So you can only have one copy of an object within a within one of these nodes. So we can do that by creating a loop for var I equals 0. I is less than array length self.contents. This is a pretty simple matter of looping over the contents array and seeing if it already contains the object. If self.contents index I equals object, then the object is already somewhere to be found in this this structure, so we can just return. And those are going to be the two cases that cause us to not add an object to an OctreeNode. So then, assuming neither of those happens, assuming that we are within the bounds of the node, and assuming that we are not already within, like we have not already been added to the node, array push self.contents the object. So we're going to add ourselves to the contents list, and then if we need to, we can split the current node. So if self.depth is greater than 0, we can self.split, and this version of the split method takes no parameters. It'll just happen based on the properties of the existing node, and then we can recursively, for var I equals 0, I is less than array length self.children I plus plus. We can recursively add the object to each of the child nodes. So, and honestly, like, I knew that hard coding, like, for I equals 0, I is less than 8, I plus plus, was going to, like, make me uncomfortable in the future. A couple of videos ago when I did that for the, like, the triangle mesh octrees. And yeah, I wish I didn't. Nobody's complained about it so far, and now that I'm, like, calling attention to it, I'm probably going to have a handful of people just, like, making fun of me for it in the comments. But, yeah, let's not say I equals 0, I is less than a magic number, I plus plus. Let's actually use the length of that array instead. Anyway, that is adding an object to one of these nodes. Removing it is going to be similar. I'm not going to bother to check to see if the object that we are removing is within the collision bounds, because, for example, if you, like, change the location of a collision object, if you change the transform position of a collision object, and you move it somewhere else and you try to remove it after that, then, like, it won't be found, and it'll just be sitting in the OctreeNode as sort of a ghost, which isn't really what you want. So instead, let's just do a for loop over the entire contents of this node. If self.contents index I equals object, this is going to kind of be the opposite of the test in the beginning of the add method. So if the object is found in the OctreeNode, then one array delete from our contents array index I one value, and also if self.depth is greater than 0, actually I'll just copy and paste again. And I'm going to need another loop counter. For j equals 0, j is less than the length of the children array, j plus plus, self.children index j dot remove the object. And then we can only ever have one copy of an object in in one of these nodes at once. So if we found it, that means there can't be any more of it, so we can stop searching, and we can say break. Actually, we can really say return, because that will end the method call entirely. Okay, checking an object against one of these OctreeNodes is going to be pretty straightforward. One, if the object is not within the bounding box of the node, we can just stop our search right there, because we know that if the object in question is not within the bounds of the node at all, then that means it also is not going to be colliding with any of the things inside it. Strictly speaking, it can, because if you have an object within the node that's, like, sticking out of it halfway, you could still have a collision with that object even if you're not colliding with a node. But in that case, that object will also be contained within another OctreeNode, which does contain collision shape that you're checking. So no big deal. So first, if self.children equals undefined, or I guess this would be synonymous with if self.depth is greater than 0, but I'm gonna say if children equals undefined instead, just in case we're checking a node that hasn't been split, because again, that won't happen until after things have already been added to the node. That's okay with the remove method, because if you get this far, you know that there's already been something added to the node. But so if our array of children nodes equals undefined, we can for var I equals 0, I is less than array length self.contents I plus plus. For each object that is in this node, we can if self.contents index I dot check object, and this is going to be where that nice like generic check object system is going to come into play, checking object against the one in question, then we can return true. Otherwise, if the children array is not undefined, so if this node has been subdivided, we can say for I equals 0, I is less than array length self.children I plus plus, and then if self.children index I dot check object, then we can return true. All right, these two, like both the if and the else sections of this branch look very similar. It's just a different array that we're checking. Whether or not we're a leaf node, whether or not we have subdivisions that we can investigate further, and there are ways that you can tidy this code up a little bit. You could just do a single loop over like a different array depending on whether or not we haven't subdivided, but not going to go that far. Anyway, if neither of these things return true, then we can return false, because there is no collision with anything inside this node. And lastly, for check array, we can do something that's going to look pretty similar, and we can say a few different things. For example, instead of saying object.shape.checkAb, we can say ray.checkAb against the bounds of ourselves. This is going to require a hit info. We do not want to pass in the hit info that we received from the checkRay method, like the call stack over here, because what would happen then is if the ray contacts with the bounds of the node, then the hit info will be filled with information about the collision with the bounds of the node instead of with the stuff that's actually inside the node, which is not what we want. The axis line bounding boxes representing things that are like representing the collision world nodes don't actually exist in the world. They're just sort of helpful bits of data structure that are there to cut down on the amount of work that we have to do. And if you do a raycast against one of those said abs, then you shouldn't pass in a hit info. If I go into shapes, did I set it up earlier so that when you do a raycast against an ab or something, where's check ray over here? Okay, so I didn't write any code so that if hit info is undefined, you could just ignore it. You could do that. I feel like it's really weird that I didn't do that earlier. So you could only update the hit info if this is not equal to undefined or something like that. At this point, though, I don't want to make changes to the to the call ab raycast code, so I won't do that. So instead, I will just I'll just sort of cheat by passing in a new raycast hit info like that, and it's just gonna sort of be discarded as soon as we're done with it. We don't really care anything for example, the precise location in space where the raycast hit occurred, or the surface normal, or anything like that. We just want to know yes or no, was there a collision between the ray and the axis aligned bounding box. Next, since when you do a raycast into a group of objects, you generally don't want to know just yes or no, was there a collision? You generally want to know the location of the nearest collision. We're not just going to do a self.contents I.check ray and then call it a day. We are going to instead, one, let me fill out the argument lists to these function calls correctly. This is going to be check ray, which takes the ray as a parameter, and the actual hit info struct as a parameter. And that's going to be the case for both self.contents.checkRay and self.children.checkRay over here. And let's say I'm going to define var result is going to be false. And then instead of just returning true or returning false, we want to check everything in the OctreeNode. So we're going to, instead of returning, say result equals true, and that's going to be the same again in both of these conditions of this branch, true and false. The only difference is what object exactly you are checking with the raycast. And then at the end, instead of simply saying return false, because this is the only return statement in this entire check ray method, we're just going to return result. Okay, that was a lot. Alright, I want to stop here because I've been talking for a long time and my throat is getting sore, but before I stop, let me go back up to ColWorld, and we're going to finish some things. One is going to be accelerator's new ColWorldOctree, and the bounds parameter that we're going to pass into the constructor is going to be self.bounds. The depth is going to be max depth, and that's going to be initializing our Octree acceleration structure. Add and remove, this is going to simply be a matter of self.accelerator.add object. Remove is going to be a simple matter of self.accelerator.remove object. Update, as I said before, this is very simply going to be removing the object and then re-adding it. Check object, we can simply, again, one line of code, return self.accelerator.check object. The object in question. Check ray is going to be a little bit more involved. We can say var hit info because I did promise that I would create one of these and return it if a collision was found. Hit info is going to be new raycast hit information. And then if self.accelerator.check ray with the parameters of the input ray and the new hit info struct. If a collision is found, if a raycast hit is found, we're going to return hit info. Otherwise, we're going to return undefined. So if a raycast is detected against the world with a ray, then what is returned is going to be a raycast hit information struct containing all the relevant information. Otherwise, if no raycast hit is detected, we are going to return undefined. And that should be it for our collision world setup. Boy. This was a lot. I haven't actually tested any of this code today. For that matter, I didn't test any of the code yesterday, but it was, last time rather. Last time was just a few simple variable definitions there, so I don't think it's as big of a deal. But I'm going to hold off on testing this until next time. If you're seeing this video being posted, then that means that everything I've written should work. If it doesn't work, I'm going to have to redo the entire thing over again.
Hey.
But next time, we're going to put our theories into practice, and we are going to do a collision world demo. And I'm going to be taking, where was it? This thing here, with its 1,000 collision objects, it's 50-odd frames per second, checking for the player's movement against all 1,000 of these collision objects. And some other hard-coded bits of awkwardness that can be cleaned up with the help of a collision world structure. And I will be inserting it into here, and we should see our frame rate going much, much higher with the help of a little bit of hierarchical organization in the form of an octree. So that's going to do it for me for today. Next time, well, I just said what we're going to do next time. After that, I'm probably going to take another bit of a hiatus from this 3 collisions thing, and then I'm going to come back to talk about matrices and some of the weirder shapes, such as oblique bounding boxes, oriented bounding boxes, whichever you prefer, capsules. I want to talk especially about some things such as collisions with terrain, because you can make some assumptions about terrain that might allow you to speed things up a little bit. More than you could perhaps with just one of these, like, general collision things, triangle meshes, whatever your terrain happens to be shaped like, as well as other miscellaneous things. I might actually start to get into like best practices when it comes to 3D collisions and stuff that I've been mostly avoiding so far. Anyway, if you want the code for this, look for the GitHub repository down in the video description. I'm really going to have to break this up into multiple commits because this is like 100 lines. I have a Patreon, so if you want to contribute towards these videos being made, look for the links to that in all the usual places. You could see some fun things like your name in the credits, hear a shout out of your username at the end of every video. About once a month I post a bit of a preview of my future plans, and if you wanted to pledge I would definitely appreciate it. Otherwise, I try to post about 2 game dev videos a week, one tutorial like this, and one Let's Make a Game, currently Bullet Hell. I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, Then Nothing Happened, Squarecrow, Sindra Larson, Posho, Gunnar Clovis, GameMaker, Emily Koyo, Edward Holt, DJ Gibbles, and Army Umbrester for supporting these videos. If you want to see your name in the credits or hear yourself shouted out at the end like this, head on over to the Patreon page down in the video description.